What's up, guys? I made the Chaser Ant LEDs better. If you happen to check out the original video, you'll appreciate the updates and extra functionality. The ants can go backwards and forwards now with a button press. You can also do customized asymmetric patterns with the lights as well, and the code is quite a bit simpler. On top of all that, there's easy expansion potential to have more than just two colors moving down the light strip. Before we get started, I'm working with a WS2812B light strip and an Arduino Nano. I have a really good tutorial video you should check out if you're completely new to this stuff. The link will be down in the description. We're doing a little more advanced stuff in this video. This update was inspired by someone who asked in the comments of my original Ant LED video how to make the LEDs go backwards. I wanted to take it a step further and make it switch directions with a button press, so I went back to the drawing board to rethink my entire approach. In the next iteration, I'd like to get this working with a potentiometer or encoder so that when you turn a knob, the lights slow down and stop, then change directions and speed up in correlation with how far you turn the knob. But baby steps. I chose a button for now because I happen to have one built onto my prototype board here that was left over from my underglow lights for RC car project. This board is portable and makes it easy to work on when I'm stuck in hotel rooms for my job. Alright, as usual, I'm going to walk through and talk about the new and improved code, since I know a lot of you guys appreciate that. The code is well documented, and there will be a link to it below if you want to just grab it and go, but be sure to hit the like button and share and leave a comment to help the algorithm out so others get the chance to find this video too. It might help to watch the previous Ant LED video, but I'm going to try to just focus on what this code is doing. I'll be brushing over some of the same stuff that's covered in the original Ant LED video and my original Fast LED tutorial video. Links will be in the description for those videos also. Okay, the includes and defines are all the same, except I did add a define for the button I'm using on this prototype board. It's using pin 3 on the Arduino Nano in my case. The adjustable section of the code hasn't changed. I eliminated a few variables from the fun variables section. We no longer need the leapfrog or increment variables from the original code. I'm still using the flip-flop variable, but I'm using it in a different way now. It controls which direction the lights move down the light strip. The LEDs array is the same old array that the Fast LED library uses. Finally, this last section has the new variables I've added for this new sketch. This is probably a good place to talk about the biggest fundamental change to the way this better Ant LED's Chaser Lights code works. You'll notice I have an array called brains commented out right here. This was my starting point when figuring out this version. I've been working with 60 LEDs, so I made an array of unsigned bytes and wrote out the pattern I wanted. On LEDs represented by 1s and off LEDs represented by 0s. The idea was to make the LEDs move down the light strip by reading out this pattern in for loops, but then move my starting index for the array each time through. So the first time cycling through the array, my index for the brains array equals 0. So it will read this whole pattern and write it out exactly like this to my light strip. The second time I read the brains array though, I'll shift my index so it will now equal 1. I'll then write out this whole pattern once again to the light strip, but starting on index 1. So LED 0 on my light strip will equal the second value in my brains array now, and so forth. You can kind of think of it like moving this entire block of values to the left and repopulating what gets dumped out on the left back to the right side, like this whole block of values is wrapped around a wheel. The inspiration behind this came from how circular buffers work. This is a little different, but it's a similar concept. I let this first brains array commented out because my default is to auto-populate the brains array based on block size and gap size like the original Ant LED video. This happens in the for loop in the setup section down here, and allows us to easily change our LED patterns at the top of the code. However, manually populating the brains array opens up some interesting options as well. First off, you no longer have to worry about making sure that numLEDs is divisible evenly by gap size plus block size. This constraint still applies if auto-populating though, just like in the previous version, and you still need to make sure that the length of your brains array matches numLEDs. But secondly, you can now manually define whatever pattern you like. For instance, you can manually define a pattern of 4 lit LEDs followed by a gap of 8 dark LEDs followed by 10 lit LEDs and so on. Burped. Excuse me. I'm a professional. Guys, look what I got for Christmas. It's Godzilla. It's a Godzilla puzzle.
Woohoo!
Last but definitely not least, the brains array doesn't have to be just ones and zeros. You can make it zeros, ones, and twos, or zeros, ones, twos, and threes, all the way up to 255 if you wanted, since the brains array is an array of unsigned bytes. Then with this variety of values, you can add more if statements below and some more red, green, blue variables to make the LEDs different colors, based on the values you assign in the brains array. I'll talk a bit more about this in a bit. I'll talk more about this in a bit. I'll also note quickly, if you did see the original Ant LEDs video, I left out the startup section from this version of the code. I just wanted to keep it clean. I just wanted to keep it cleaner since the startup section was just for aesthetics. You could still add it in from the old code if you wanted to. Another viewer also suggested something recently to simplify the startup section, and I'm going to experiment with it a little bit more. I'll throw out another update video or add that into the next encoder iteration video in the future. Encoder potentiometer, you know, with the knob. Okay, moving on through the code. This other uncommented brains array is just declaring the array since I have it auto-populating by default. This index variable is what we're using to index through the brains array. We give it a starting value in the setup section based on the state of the flip-flop variable, which defines whether the lights are moving forwards or backwards. I've also added a bool variable for a button debounce since I'm using a push button to change directions. The setup section has a couple changes as well. This stuff is still all the same, but I've added pin mode to declare pin 3, my button pin, as an input with a pull-up resistor. If you didn't know, the pins on an Arduino can be either inputs or outputs depending on how you set it up with the pin mode instruction. The input pull-up you see here is setting it as an input and telling it to use its internal pull-up resistor. Pull-up and pull-down resistors, without getting too into it, basically just ensure that the button stays in a stable voltage state and they don't false trigger. A pull-up resistor pulls the voltage at the pin up to a stable 5-volt state, so to trigger the pin, it needs to connect to 0 volts, which is how the button is set up in my case. If you don't use the internal pull-up resistor, you need to add that stuff externally for your button to work reliably. This next part is just setting index to its proper startup state based on how you set flip-flop up at the top. Remember, flip-flop is now being used to determine whether we're running the lights forwards or backwards down the strip. And this section is what you need to comment out if you want to manually define the brains array. It's what auto-populates the brains array. And this part here is why you need to make sure that gap size plus block size goes into numlets evenly when setting those values up at the top. I'm not going to go over how this part actually works since I covered that in the last video. It's slightly different than what I was using in the running section of the previous code, but it's still the same principle. And also, if you're commenting this out to manually populate the brains array, don't forget to switch the brains array you're using up here. Alright, we're almost through this nonsense. On to our loop section. The very beginning is our button evaluation and one-shot logic. The first if section requires both the button to be pressed and the button debounce variable to be false. If this happens, it changes the state of the flip-flop variable, which changes the direction of the lights down below. We then set the button debounce variable to true so that we don't instantly change the flip-flop again on the very next loop cycle. This is what a one-shot does. It makes sure your button press does what it needs to do for one and only one scan cycle of the processor. There's more to be said about button debouncing with Arduino, and I'm hoping to get into that more in a future video, but for now, this simple one-shot logic works for what I'm doing. The next two if statements are there just to correct the increment or decrement we just did at the end of the code down here if we're switching directions due to a button push. The last if statement in our button one-shot logic requires the button to be released and the button debounce variable to be true, which it should be since we just made it true in the above if statement. So while the button is held down, neither of the one-shot if statements should execute more than just the one time when we first pushed the push button. Okay, the ants go marching forwards, or somewhere, looking for your picnic baskets. The first if statements in both the forwards and backwards section are just looking for the state of the flip-flop variable to know which way we want the ants to go. Then we execute our for loop for said direction. The for loops either increment or decrement. The first if statements in this for loop adjusts our index variable for the case when index already equals numLEDs going into the for loop. The for loops in each direction section simply write all 60 LEDs once and then move on to the rest of the code down here where we show the LEDs, do our delay, and then increment or decrement the index variable before we loop around and go back into the for loops once again. The magic that makes the lights actually move down the strip happens from those index changes at the very bottom. It shifts our starting point in our brains array when we're writing the LEDs in the for loops. The rest is pretty straightforward. We evaluate the brains array location based on the value of the index variable. If it's a 1, we write the first LED on the light strip according to the red, green, or blue values we've set at the top of our code. If it's a 0, we write the first LED on the strip according to the red gap, green gap, and blue gap values. This makes our blocks and gaps move down the light strip. Cool. There's expansion potential here, as I mentioned before. Not only can you manually populate the pattern in the brains array, but the values in the brains array don't have to be just 1s and 0s. You could add 2s, 3s, or 4s, etc. to the brains array and then add more if statements here to evaluate those new values. Then add some new red, green, and blue variables at the top of the code to store those color values so you can have many different colors moving down the light strip instead of just 2. Sweet. Alright, I think it's time to wrap up, but there's a couple things left to note. After those 2 if statements where we write to the light strip, we increment our index variable so that we write the next LED on the next for loop iteration. We then have one more if statement to deal with resetting that index variable if we overflow past the length of our light strip. Also, lastly, all of this ants go marching backwards nonsense is all the same stuff, just backwards. I'm writing the LEDs from the end of the light strip to the beginning. It was just easier to figure out that way. I guess. I don't know. I wrote this code like several months ago and I'm just now getting around to making the video because life is anarchy. Oh, and also when I say the ants go marching forwards, it's actually backwards towards the front of the light strip and vice versa. Anarchy. Alright, later guys. Don't forget to like and subscribe and stuff. This is Live Meet Lightning. Bring a little lightning into your life.